Hello. Hello all. Good morning to all. Okay. So as per our schedule, today we have a planning to cover the ratio and the age part. That is the second module of our aptitude sections. Okay. So this is as per the mail. We have the quiz session after the aptitude session of the ratio. If I talk about the rules of the quiz, they are the 10 questions, 10 minutes. There is a negative marking of 0.25. And if you secure 60%, then we awarded a e-certificate. As I said, there's a total 10 question and there's a 10-minute duration. Link will be automatically closed after 10 minutes. See, so as I covered initially the modular percentage on the 13th September of 2020, and today we are going to cover the ratio module, in which if I talk about the chapters that comes in the ratio module, then there is a six chapters, six chapters of the ratio, six chapters that comes, six chapters that comes in the ratio. That is the basics of the ratio is partnership, mixture and alligation, time and work, and the pipe and crystal. In the previous module or in the previous webinar, as I told you that once the concept of percentage, if you have a proper understanding of the percentage, what is percentage, then you can easily solve each and every questions of the five chapters as mentioned by me. That is the basic concept of percentage, profit and loss, discount, simple interest, and the compound interest. Today, if I said what is the requirement, what do you need to understand to solve these six chapters? So according to me, if you have a basic understanding of ratio, that means what is ratio. If if you know the meaning of ratio or how to apply the concept of ratio in the different questions, then I think if you have a proper understanding of the ratio, then you can easily solve these six chapters. That is a ratio, there is a questions, simple questions based on the ratio is partnership, mixture and alligation, time and work, and the pipe and crystals. So today I cover the basic steps of the ratio, and I show you how you apply the concept of ratio in the different questions, in the different varieties of questions of the different chapters. Only by the one concept, what is ratio? So let's come to the point. Uh, I start. I start with the ratio. What is ratio? Okay, then what is it? If I show you what is ratio, then simply it says that when you do the comparison between two things, then ratio is a medium to show the comparison between any two things, like between the age of the two person, between the distance, between the height of the two person, between the speed of the two person, anything. If you want to compare the two things, then you can easily use the concept of ratio to explain the steps. And if I define, then ratio may be from the homogeneous quantity or the heterogeneous quantity. If the two quantity is of homogeneous, that means if they are of same nature, then there is a no unit of ratio, it is a unitless. And if it is a heterogeneous quantity, then we have some unit of ratio. We can express ratio in the three things: fraction, percentage, and the decimal values. And in the complete six chapters, I used only one. I will use only one property of ratio. That is, if if the ratio is given in the form of A by B, then if you multiply the numerator and the denominator by n or by any constant quantity, the ratio is going to be same. Ratio is going to be a same. It is not going to be a change. Then just I think this property is sufficient to solve any varieties of the questions related with the ratio. Okay, so I just elaborate the concept of ratio a little more. Then I come to the point. Then I come to the questions and how to apply the concept of ratio on the questions. See, ratio. What I am saying, ratio is used to compare the two quantities, right? Suppose that if anyone says that the age of person, the age of person A is 40 years and age of person B, age of person B is 10 years, right? Then then if I want to compare the age of A and the age of B, then by the ratio we can easily do that, right? By the ratio we used to compare the two things. Like if I want to compare the age of person A to the age of person B, then I just compare, that is age of person A by age of person B is equal to 40 years by 10 years, that is 4 is to 1. That means the age of A is four times age of A is four times the age of B. That means if I elaborate it further, it means that if the age of A is 4 unit and if the age of B is 1 unit, then difference between the age of A and the age of B is 3 unit. If I take another example, suppose that there is a box, and in a box there is a three quantity, that is A, B and C. Suppose the quantity of A is 10 kg, quantity of B is 20 kg, and quantity of C is 30 kg, right? Then if I ask you what is the ratio of A is to B, then what is the ratio? Ratio means to compare the two things. And if I know what is the quantity of A and what is the quantity of B, then we can easily find the ratio between the A and B. So in the box, if anyone asks me to find the ratio between A and B, so we just compare the A quantity with the B quantity, that is 10 kg, to the quantity of B, that is 20 kg. That means ratio is 1 is to 2. If anyone asks what is the ratio of B is to C, that means if I know the quantity of B and if I know the quantity of C, then you can easily calculate the ratio between B and C. That means here the ratio between B and C, that means I have to find the quantity of B and quantity of C and just compare the quantity of B to the quantity of C. The ratio, the the difference, that means the division of B and C gives you simply the ratio. That means the quantity of B here 20 kg and quantity of C here 30 kg. That means ratio is 2 is to 3. This is the ratio between B and C, and this is the ratio between A and B. Suppose that if the B quantities, if the B quantities, this is A, this is B, this is C. Suppose that A is 10 kg and B is 35 kg, and C is suppose that 21 kg, right? And if again, if I want to find the ratio between A and B, then A and B ratio is 10 kg to 35 kg. That means 2 is to 7. If I ask, if anyone asks what is the ratio between B and C, then ratio between B and C is 35 kg by 21 kg. That means 5 is to 3. Then if I further elaborate this concept, then here from here we got that A is that is A is 2 unit and B is 7 unit, and from this ratio we got that B is 5 unit and C is 3 unit. Then from this ratio of A to B, I am saying that B unit is 7 unit. That means the quantity of B in the box is 7 unit. And from this ratio, I am saying that no, the quantity of B is 5 unit. When I compare this B and C, then I am saying that quantity of B is 7 unit. And from when I compare A and B, then I am saying that quantity of B is 7 unit. That means from the from the two comparison, what quantity of B I have taken? I have taken the same quantity of B in the box. That means for the comparison, I am taking the same quantity of B that is present in the box. But in the first comparison, I am saying that it is 7 unit, and I am saying 7 unit, and in the second comparison, I am saying that quantity of B is 5 unit. Then it is conflicting. That is, it is conflicting. I am saying the two quantity of B in the two different comparison, that is conflicting with each other. Then I need to correct it. The confliction that comes between the two comparison, I have to know in both comparison the quantity of B in the terms of unit should be same, right? Then I just manipulate the ratio by the only one property. What is the property? If A is equal to 2 and B is equal to 3, then ratio between A and B is 2 is to 3. And if I multiply A with the 5 and B with the 5, that means if I multiply A and B with the same number, that is with the same integer, the ratio is going to be a same. It is not going to be changed. This is the one property which I am using in all the 5 and 6 chapters. I don't think any other property is required to solve the concept of ratio, or to solve the questions based on the ratio. Then here A, B, C, A, B, and C. When I compare A and B, I am saying that it is 2 and 7, and from the second comparison, I am saying that B is 5 and C is 3, right? Then this is the confliction. It is 7 unit and it is a 5 unit, which is contradicting each other. Then I need to correct it. I need to eliminate this contradiction. For this I just multiply this 7 with the 5, and if A by B is 2 is to 7, and if you multiply 7 with the 5, then you must multiply the A, that is 2 unit, with the 5. This is the property that we just saw, right? That means if you multiply B with the 5, then you must multiply A with the 5, so that the ratio will be maintained. It is not uh, it should be same, right? So if you multiply B with the 5, then you must multiply A with the 5. Again, B is 35, right? B is 35. Then if you multiply here this B with the 7, then you must multiply C, that is the 3 unit with the 7. Now A is 10, B is 35, and C is 21. That means the ratio between A, B, and C is 10 is to 35 is to 31 is to 21. That means what is the conclusion? Conclusion is why we need uh, to maintain this ratio same, because we are using the same quantity of B from the box, and it must, the unit of B must be same when you do a comparison of A and B and B and C. If the quantity of B is same, then its unit must be same. This is the basic concepts or logics, right? By and by this only concepts and this logics, I am going to show you the various questions, and I apply just simple this concept. Okay, what is ratio, and why we need to maintain the units of the A and B same. Okay, then just come to the questions, and I show you how to apply the concept of ratio. Just only this concept, what is ratio, in the questions, and we can easily solve the each and every questions of aptitude without any formula, without any variable, or without any tricks. There is no requirement of any tricks to solve any questions of the aptitude. It is maximum more than 95% questions you can solve of the aptitude only by the logics, only by the concepts. Okay, then I come to the first question, and let's see apply the concept of ratio in the questions. Okay, see, this is the first question. This is the first question of the ratio. It is saying that a vessel contains 40-liter mixture of milk and water, in which percentage of milk is 30%. How much water should be added? How much water should be added so that percentage of milk becomes 20%? Okay, that means there's a vessel which have a 40-liter mixture, and in which percentage of milk is 30%. Okay, let's see. It is saying that there's a vessel, there's a vessel, there's a vessel which have 40 liter, which have a 40 liter solution, which have a 40 liter solution of the milk and water, of the milk and water, right? And it is saying that the percentage of milk is 30%. The percentage of milk is 30%. Then what is the quantity? Then what is the quantity of water, right? Uh, it is saying that there's a container which have a 40-liter mixture in which the percentage of milk is 30%. Okay, then how much water should be added? How much water should be added in this container so that the concentration of milk is reduced to 20%? Now how much water we should add so that the concentration of milk becomes 20% from the 30%? Okay, see, suppose in this container, if the concentration of milk is 30%, then the concentration of water becomes 70%. Obviously, in the complete in this vessel, it is saying that the concentration of milk is 30%. Then obviously the remaining concentration is water. That means the concentration of water is 70%. Similarly, it is saying that we add some water in the vessel. We add some water in this vessel. Suppose if I say the concentration of this vessel is m1 liter. Let's say it is given that it is a 40 liter. I take it. Suppose we have a m1 liter m1 liter in this vessel, and if we add some water, then obvious the concentration of the quantity of the milk and water must be more than m1 liter. It becomes m1 liter plus the quantity of water which we add in this vessel. So suppose we add some water, and it becomes m2 liter, right? And if I am saying the concentration of milk here is 20%, then the concentration of water becomes 80% in this vessel, right? Then if we observe the statement of questions, then it is saying that we add some water, suppose we have some milk and water here, and we add some water in this vessel. Then obvious the quantity of milk is going to be the same. If I am saying in this 40 liter, if the quantity of milk is 21 liter, then then there is a 21 liter milk in this vessel also, right? Because we add some water, the quantity of milk is not going to be changed in any case. We add water. Okay. Then what is the quantity of milk here? What is the quantity of milk in this container? Then what you say that 30% of 40 liter, this is the quantity of milk. What is the quantity of milk in this container? Then you say 20% of m2. If I say the concentration in this container is m2, then 20% of m2. If I say what is the quantity of water, then you say the 70% of 40. Or if I say this is the m1 liter, then 70% of m1. What is the quantity of water here? Then you say 80% of m2. Okay. But we know the quantity of water is changed, but the quantity of milk in this vessel and this vessel is remain constant, is going to be the same. That means the quantity of milk, if you calculate the quantity of milk from here, and if you calculate the quantity of milk from this expression, it is going to be the same. It is not going to change. That means that 30% of m1 is must equal to 20% of m2. That means m1 by m2 is equal to 20 by 30. That means 2 by 3. Then what is the meaning of this ratio? If m1 is 2 unit, then m2 is 3 unit. That means what is the m1? M1 is the concentration. M1 is the uh, quantity of mixture in the vessel, in the first vessel. What is the 3 unit? 3 unit is a quantity in the vessel, in the second vessel. That means the quantity is increased from 2 unit to the 3 unit. Of course, it is going to be a change because we add some water in the first vessel. Then of course the quantity is going to be a change. Then here from the concept of ratio, we know that how much it changed. It is changed by the 1 unit. And it says that the m1 is 2 unit. But what the question says? Question says that the quantity of mixture in the first vessel is 40 liter. It is mentioned in the question. That is the quantity. That is the quantity of milk is 40 liter. There is a 40 liter mixture in the first vessel, right? That means the value of 2 is 40 liter. Then value of 1 becomes 20 liter. Then how much water we added? We added the 1 unit water. That means what is the value of 1 unit? Then value of 1 unit becomes 20 liter. This is the answer. That means if you add 20 liter water in the first vessel, then the concentration of milk is changed from the 30% to the 20%. I am explaining you the questions from the sketch. That's why it takes time. Then I don't think this question is more than 5 to 10 seconds to solve. There is just one approach, that we need to find which concentration or which quantity is going to be a constant. If if the milk is constant in the both vessel, then go with the milk. If the water is constant in the first vessel and the second vessel, then go with the concentration of water. And just compare the two ratio of the M1 and M2, and just find the value of the units. Here we add the 1 unit water in the first vessel, so that the concentration of milk is changed from the 30% to the 20%. Okay, let's come to the second questions of the aptitude. Second question is saying that a bucket contain a mixture of two liquid A and B in the proportion 2:3, right? If 40 liter of mixture is replaced by the 40 liter of liquid B, then the ratio between two liquid becomes 1:4. Find the initial quantity of the mixture. Find the initial quantity of the mixture. The question is saying that, right? Okay. That means the ratio between A and B is 2:3, and 40 liter of mixture we replace by the 40 liter of liquid B, then the ratio becomes 1:4. Okay. Then it finds what is the initial quantity of mixture. Okay, fine. And the first answer is 20, right? The answer is first answer is B, option B. Okay. Then I come to the second question. 2:3, 40 liter replace. Okay. See, the question saying that the question is saying that a vessel, a first vessel, there's a mixture of milk. There's a two liquid A and B in the proportion 2:3. In the proportion 2:3. Okay, that means there's a two liquid A and B. There's a two liquid A and B, and it is saying that the ratio between the two liquid is 2:3. Okay, then suppose that this is the A and this is the B, right? And ratio between the 2:3 is 2:3. And again, it is saying that we replace the mixture. How much mixture we replace? We replace 40 liter of the mixture. We replace 40 liter. That means we withdraw 40 liter of the mixture and replace by the 40 liter of liquid B. That means we subtract the 40 liter mixture from here, and we add 40 liter of liquid B. This is what the question is saying. And after adding the 40 liter liquid B, the ratio becomes 1:4. 1:4. This is what the question says. Then it asks us, what is the initial quantity? What is the initial quantity of the mixture? It asks this. What is the quantity of initial quantity of this mixture? Okay. See, so my first concern is, what is the ratio? What is the meaning of ratio? Ratio of A and B is 2:3. Then how would calculate the ratio? If the ratio between the two mixture comes as 2:3, then how it find the ratio of A and B? Then of course it anyone calculate the quantity of A in this container, and again they calculate the quantity of B in this container, and again compare the quantity of A and the quantity of B in this vessel, and says that okay, the ratio is 2:3. That means there is some quantity of A, there is some quantity of B, and he compared this quantity with this quantity, right? And says that okay, the ratio is 2:3. Now again he says that okay, he withdraw the 40 liter mixture. He withdraw the 40 liter mixture from this, right? Then again if I withdraw the 40 liter of the mixture, then the ratio is going to be a same. The ratio is going to be a same, that is 2:3 only. How? Suppose that we have a mixture of sugar and water. We have a mixture of sugar and water, right? And if you taste the mixture from this portion, or from this portion, or from this portion, right? It is the sweetness of the portion. If you take portion from here, if you take the portion from here, if you take the portion from here, it's going to be the same. It is not going to be changed. What does it mean? It means that it is a homogeneous mixture. It is a homogeneous mixture, and the concentration of the sugar and water in each and every portion of the container is going to be the same. It is not going to be changed. It is always remains constant. That means if I say the concentration of sugar in this portion is 40%, then concentration of sugar in this portion is also going to be a 40%. The concentration of sugar in this portion is also going to be a 40%. It is not going to be a change. It will always remain constant because it is a homogeneous mixture, right? Then if you withdraw the 40 liter mixture, then also suppose this is initially this is the quantity, and you withdraw some, and now the quantity left is in this container is this, right? Then if I take the example of sugar and water, the sweetness of the sugar and water from this portion and from this portion is going to be same. It is the level of concentration of sugar here and here is same. It is not going to be same. Then here the ratio between A and B is going to be the same. That is 2:3 only. It is not going to be changed. Now it says that it is replaced by the 40 liter of liquid B. That means we add 40 liter 40 liter 40 liter quantity of B in the vessel. Now as we add the quantity of B, then of course the ratio becomes changed. It is changed to 1:4. Then how again it calculate the ratio? Again it calculate the quantity of A, and again it calculate the quantity of B, and just compare the quantity of A to the quantity of B, and he got the ratio 1:4, right? Then why it is changed? Then of course we add some quantity of B, then obviously the quantity of B change, and the ratio, of course the ratio is going to be changed, right? But we add the quantity of B, right? We add the quantity of B. We do not disturb the quantity of B. We do not disturb the quantity of A. I mean to say that the quantity of A left in the vessel. Suppose that it is a 8 liter. It is a 8 liter. If I say the A is 8 liter, and if you add the quantity B, then quantity of B is going to be changed, but A is always remains constant. A is always remain to be a 8 liter only. It is not going to be a change, right? Then here we say that we say that the A is 2 unit, but if we add 40 liter, and then we say that the A is 1 unit, then it is contradicting with each other, because we know that we add the quantity of B. A should be constant. Then we must make this one to the 2 unit of. Then of course we use the property of ratio. That means if you multiply this one with the 2, then you must multiply this 4 with 2. That means it becomes 2:8, right? If a by b is equal to 2/3, and if you multiply this by 2 and this by 2, the ratio is going to be the same. It is not going to be changed, right? Then 2:8. Then what we see? We see that the 3 is changed to 8. 3 is changed to 8, and A is constant. A is constant. Okay, now it is okay to me, right? A is constant, of course. A should be the constant, and B is changed because we add the 40 liter quantity of B. Then 3 is changed to the 8. That means there is change of 5 units. There is change of 5 units whose value is 40 liter. That means 5 unit value is 40 liter, and 1 unit value is 8 liter, right? That means if the value of 1 unit is 8 liter, then what is the value of 2 plus 3? 5. Then value of 5 is 8 into 5, 40 liter. That means at this position, the quantity of mixture is 40 liter. Question asks us what is the initial quantity. And what is the initial quantity? Initial quantity is this. That means this 40 liter, and if you add the 40 liter in this, then 40 plus 40 it becomes 80 liter. That means means the initial quantity of the mixture is 80 liter. The answer is 80 liter. Or you can calculate as the quantity of the mixture is same as the quantity of mixture. Okay, as the quantity of mixture is same as the quantity of mixture, as the quantity of mixture replaced here is 40 liter and we replace with the same quantity, then you can calculate the final quantity from this also. That means if the value of 1 unit is 8 liter, then value of the 8 plus 2 10 is 10 into 8 is equal to 80 liter. Right? Then this question is hardly of 5 to 10 seconds. I am explaining you each and every concept. That's why I'm taking so much time. If you solve by your own, if you're proper understanding of percentage, then it hardly takes 5 to 10 seconds to solve this question. Okay, I come to the third question of the aptitude. Third question. See the question is saying that the average pocket money of 35 students, it is saying that the average pocket money of 35 students is 550, and if 5 new students join the group, the average pocket money reduced by rupees 5. Then it asks find the average pocket money of 5 new students. Then it asks that find the average pocket money of 5 new students. Okay. Then initially the average pocket money of 35 students is 550, and if 5 new students join the group, the average pocket money reduced by rupees 5. Then find the average pocket money of 5 new students. Okay. 35 students, 550. Then it says that the average pocket money of 35 students, the average pocket money of 35 students is rupees 550. And if five new students join the group, then the average pocket money is reduced by rupees 5. That means it becomes 545. It becomes 545, right? Then again, this question is easily solvable, is easily approachable by the concept of ratio. Okay. See, initially there is a 35 students. Initially there is a 35. Initially there is a 35 students, and if the 5 new students join the group, now the number of students becomes 40. Now the number of students becomes 40. Initially there are 35 students. Now the number of students is 40. Then if I ask you what is the ratio is just a comparison between the number of students initially and the new number of students. Then if I ask you the ratio, then if I ask you the ratio, then you just compare these two numbers, that is 35 students and the 40 students. Okay. Then what is the ratio? Then the ratio is 35 is to 40. That means 7 is to 8, right? This is the initial and this is the new. That means the initially, if I say in the number of ratio, then initially the number of students is 7 units, and when the 5 new students join the group, then the new becomes 8. Okay. Then this question is easily solvable by the line method, right? Then suppose it says that initially there is a 3 4 5. Initially there is a 7 students. And the when that means if I say in the terms of ratio, then initially there is a 7 unit students are there, and if the 5 new students join the group, then this unit becomes 8. Then there is a one additional unit, then it becomes 8. Initially there is 7, and when 5 students join, then it becomes 8, right? And it says that initially the average pocket money of the students is 545, is the 545. That means the average pocket money of this is also 545, 545, 545. The average pocket money of all these students is 545, right? And if I add this 5 students, that is equivalent to the 1 unit. When I add this student in the group, the average pocket money is going to be reduced. Now then how much it is reduced? It is reduced by rupees 5. It is reduced by rupees 5. That means the average pocket money of the all 8 students, of all the 8 unit students, becomes 540, becomes 540, 540. The average pocket money of this student also becomes 540, this also becomes 540, and this student also becomes 540, 540. Then it asks, what is the average pocket money of this student? What is the average pocket money of this unit student that is equivalent to the 5 new students? Then it asks for the to find the average pocket money here. Okay, see, then here I see we know the concept of average, right? The summation of all this, and summation of all this must going to be the same, must remain constant. We know the average from the average, that if you calculate the average with this 540 with the 8 students, and if you calculate the total amount with 545 with 7, and the average pocket money with this, it must be the same, it must going to be the same, right? Then here we find that in each for each unit of a student, there is a 5 unit less. It is 540, 550 and 545, right? It is a 550, it is 550, 550, it is 550, and it is 550, it is 550, and it is reduced by 5 when the five new students comes. Okay, then it is a 550, and it is a 545, it is a 545, and it is a 550. I again redraw it. Let's see. 1, 2, 3, 4, 5, 6, 7, and 8. The average pattern of this is the 550, 550, 550, 550, 550. And when this new student comes, then it is reduced by rupees 5. That means it becomes 545. It becomes 545. Okay. Then what I observe from here, for the every one unit student, it is it is increased by 5. That is plus 5 here, 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 and plus 5 here. That means 1, 2, 3, 4, 5, 6, 7, 35. There is a total increment of plus 35 here. Then to maintain the same amount from the top and from the bottom, we must reduce, we must deduct minus 35 from this amount. That means the average pocket money of 5, the 5 new students, is 545 minus of 35. That means 510. That means that this is the answer. The average pocket money of 5 new students is 510 rupees. Then you can, I mean to say that if you have proper concept of ratio, then you can easily solve this question within the one line only. That means it is a only one line question. That's all. That means we apply the concept of ratio uh, in the terms of average, right? Then this is answer. 510 is the answer. Uh, option is C. Option is C. Come to the next question. Question number 4. Question: in a city, out of total population in 2/3 are a male. If the number of male increased by 15% and the overall population of a city would increase by 12%, then find the how much percent female population will increase, right? It says that if the total population is 3, then in the 3 unit, 2 units are the male. 2 units are the male. Okay. And if the number of male increases by 15%, then overall population of a city would also increase by 12%, right? 15, 12, and 2 I thought. 15, 12. Okay. See, it is that means that 2 by 3 are the male. That means that 2 are the male population and 3 are the total number of population. Total number of population are there. 3 unit are the total population, and in the 3 unit of the total population, 2 unit are the male. 2 unit are the male population. 2 unit are the male population, right? And again it is saying that, if the number of male increases by 15%, then overall population of a city will also increase by 12%. It is saying that if the male is increased by 15%, right, then overall, that means the total population is increased by 12%. Then what is the increase in the female population? Then what is the increase in the female population? There's a four option: 4%, 5%, 6%, and 8%. Option is 4%, 5%, 6%, and 8%. Okay. Then how it calculate the ratio? If I come to the basic concept of ratio, how it calculate the ratio? It just calculates the total population in a city, that is a 3 unit, and the male population, that is a 2 unit. And I mean to say that how it calculate the ratio is just calculate the number of male population and the number of total population in a city, and just compare the male population with the total population. Then the ratio comes to the 2 by 3. Okay. Then it says that the three are the total population, in which two are the male, then must one unit are the female. If the total population is 3 unit and the 2 unit is the male population, then one unit must be the female population, right? And again it says that the total population is increased by 12%. That means 12%, 12%, and the 12%, and the male population is increased by 15%. And male population, that means if this increased by 15%, this increase again, if I just apply the concept of ratio in the terms of line method, right? Then there's an increment of total increment of 36, in which 30 increment by the male. Again, I am repeating, if the 36 uh, percent increment in the total, and in that total 30% increment by the male, then there is a must 6% increment by the increase by the female. That is the simple answer is 6% is the increase in the female population. 12% in the if the 12% is the increment in the total population, and in that if the 15% is the increment by the male population, then there must be a 6% increment by the female population. The answer is 6%. Hardly 5-second questions. If you know the proper concept of ratio, what is ratio? What does it mean by ratio? I come to the next question. That is the fifth and the last question of the today's session. The fifth question is saying that the present age of A is 18 years more than that of B, and the ratio between the age of A 4 years before and the age of B 2 years after is 2:1. Find the present age of B. I am again repeating the question. It is saying that the present age of A is 18 years more than that of B, and ratio between the age of A 4 years before and age of B 2 years after is 2:1. Then find the present age of B. Then I am saying that there is no requirement of any variable to solve this question of age. If you have proper understanding of the ratio, then you can easily solve. There is no requirement of any variable to solve the question of age. Let us see. See, if it says that the age of A is 18 years more than the age of B, right? This is the A and this is the B. Then if it says that the age of A is 18 year more. Age of A is 18 year more than the age of B, right? That means A is 18 year older than B. And again it says that ratio between the age of A 4 year before and age of B 2 year after. The ratio between the A 4 year before, then there is some age of A, right? There is some age of A. There is some age of A, 4 year, and age of B 2 year after, there is some age of B. Then how we calculate the ratio? We just calculate the age of A from the present. What is the age of A 4 year before, and what is the age of A 2 year after, and we just compare this age and with this age, then ratio becomes 4:1. That means the ratio becomes 4:1. If we compare this age and this age, then the ratio becomes 4:1, right? Then that means the age of A 4 year before and age of B 2 year after, there is a difference. There is a difference of the age of 3 units, right? If I compare the age of B at this position and age of A at this position, and we compare, then ratio becomes 4:1. That means the difference of the age of A and B is 3 units, right? Then 3 unit, the difference of the age in the terms of unit is 3 year. If I calculate the age in the terms of year, then it is 18 year, 2 year, and the 4 year, right? That means the in the present difference of the age is 18 year, and if I add the 4 year, as I calculate the age of A 4 year past from the present, and I calculate the age of B in the future. That means after 2 year. That means the difference between the age of A and B in the years is 18 year, 4 year, and 2 year. That means 18 plus 4, 22, and plus 2, 24. That means the value of 3 unit is 24 year. Then the value of 1 unit becomes 8 year. Then the value of 1 unit becomes 8 year. And what is the question? Question asks us find find the present age of B. Find the present age of B. And what is the present age of B? Mm, that means the value of one, then the value of 1 unit is 8 year. That means that means here I am saying this is the 1 unit, this is the 1 unit, and this is the 4 unit. That means the age of age of B in the future. That means after 2 years from the present is 8 year. Then what is the present age of A? What is the present age of A is 8 year minus 2 year. That means 6 year. That means the present age of B is 6 year. This is the answer. Option A, 5. Option A, 6 year. That means if you have a proper understanding of the concept of ratio, then I don't think there's any requirement of variable to solve any questions of the ratio. Each and every question of all the 6 chapters, that is the ratio, is partnership, mixture and irrigation, pipe and crystals, and the time and work, you can solve by the logics, by the concept only. There is no requirement of any variable, there is no requirement of any tricks, and there is no requirement of any formula to solve any questions of the aptitude. If you have a proper understanding of the logics and the concepts. I think in the complete aptitude, if I divide the aptitude aptitude in the 3 modules, then in the first module there's a requirement of concept of percentage. What is percentage? In the second module, uh, there's a requirement to understand what is ratio and how to apply the concept of ratio in each and every question. How we apply the logics of the ratio in the questions, right? And in the third module, if you have proper understanding of the distance is equal to speed into time, and how you relate this speed, distance, and time, and if you have a proper understanding of the relation between the speed, time, and their dependencies, then you can easily solve the boat and stream questions, time and distance questions, and the train questions without any formula or the variable, by with the only approach and the concepts. Okay. Then at the last, there's a one puzzles. Then I just to go through these puzzles, as the puzzles and the attitude puzzles is usually asked in our VLSI industries, right? So the puzzles is saying that you have a full bucket contain 24 liter of liquid. Uh, you also have a 3 empty bucket, one of 5 liter, one of 11 liter, and one of 13 liter. And how could you divide? How could you divide this is the puzzles which says that you have a full bucket containing 24 liter of liquid. You also have a 3 empty bucket, one of 5 liter, one of 11 liter, and one of 13 liter. And how could you divide the 24 liter of liquid into 3 parts so that you have a 3 bucket containing 8 liters each, right? That means it says that you have a 1 bucket of 21 liter, that is a full of liquid, and you have a 3 empty bucket of 5 liter, 11 liter, and 13 liter, and you have to distribute this 24 liter of liquid in the 3 buckets containing 8 liter each, right? Okay. See, then if the puzzles saying that 24 liter, 13 liter, 11 liter, and a 5 liter, and we have a 24 liter, that is a full, and we have to distribute this 14 liter in the 3 buckets containing 8 liter of liquid each. Then how you make distribution with the help of this 3 empty bucket, so that you can divide this 24 liter in the 8 liter each. Okay. uh, okay, then in the first step, then in the first step, what I am doing, just fill this 13 liter bucket. Then if you withdraw the 13 liter liquid from this 24 liter bucket, then the remaining is, here we got 13 liter, and here we got 11 liter liquid, right? Okay. Okay. Now in the second step, what I am doing, uh, in this we have 11 liter, and just fill this 5 liter bucket. Just fill this 5 liter bucket. That means withdraw the 5 liter from this 10 liter, from this 10 liter bucket. That means if you withdraw the 5 liter, then in this bucket we have a 5 liter, and here we have a 8 liter, right? And this bucket is still empty. That means this is a vacant, right? We do not have a any concentration of liquid in this uh, 11 liter bucket. In the third step, what I am doing, 8 and 3, right? Uh, okay, okay. In this we have 8 liter, right? And uh, fill this 11 liter. This fill like this 11 liter with this 8 liter bucket. That means now we have if you fill this 11 liter if you fill this 11 liter bucket with the 8 liter, then it becomes empty. And it have a 8 liter, and here we have a 5 liter, right? In the fourth step, what I am doing, uh, fill this bucket with this 5 liter, that means 11 liter. We have a 5 liter here, here we have a 8 liter, and we have here 0 liter, right? Now we have a 8 liter in one bucket, right? Now I want 8 liter in the remaining two buckets. Okay. And this bucket already have a 5 liter, right? This bucket is already uh, have a 5 liter. uh, then what do you do? Just fill this bucket, with a 5 liter. That means in the fifth step, we have 11 liter. Here we have a 0 liter, we have a 8 liter, and we have a here 5 liter, right? And uh, and and in the sixth step, fill this bucket with the 8 liter, right? That means here we have a 3 liter, and fill this bucket with the 8 liter, and already we have a 8 liter here, and we have a here 5 liter. Okay. Now at this step, in the two bucket we have a 8 liter. In the two bucket we have a already have a 8 liter, right? Now in the seventh step, just fill this bucket, with the 5 liter. That means here we have a 8 liter, 8 liter, and the 8 liter, right? Uh, that means the question asking us how to fill the 24 liter, uh, so that how to distribute that 24 liter bucket, so that in each and every bucket we have a 8 liter liquid. That means in the three bucket we required 8 liter liquid in the three bucket. Then by these seven steps we can uh, easily distribute the 24 liter bucket into the three 8 liter individual bucket. Okay. So this is what this type of puzzles which was asked in our Velasai industry. And I am again repeating that I am again repeating ki in the aptitude we have a three models, that is the ratio, percentage, and the time and distance, right? Time and distance. For the percentage we require one is what is percentage, and here we require what is ratio, and here we require distance is equal to speed into time, d is equal to s into t, d is equal to s into t. if you have proper understanding of these three concepts and how to apply the concept of percentage and the ratio in various varieties of questions, then you can easily solve uh, each and every question of the aptitude without learning any formula or the variable or the tricks. Only by the logics, only by the concepts, you can solve various questions of the aptitude. So that's all for the today's webinar. Next, we have a next webinar. We have a next webinar on the 27th of the September. That is the speed, time, and distance. That is I cover the concept of speed and the concept and the relation between the speed, time, and distance, and a few questions and how to apply these relations on the questions on the these three from the three uh, on the chapters that is on the chapter time, distance, train, and the boat and stream. So that's all for today's webinar. Sir, I send you the link to your email for the quiz session.